Balanced forces and unbalanced forces. Let's start. Balanced forces are equal forces that act on an object from opposite sides so the object doesn't move. As you can see in this image here, a person is exerting force to the right side, which is the green arrow, while another person is exerting force to the left side, which is the pink arrow. Both arrows have the same length. This shows that the force exerted is equal but from opposite directions. In this case, the object doesn't move. That means the object is stationary. Okay, now for the unbalanced forces, it is unequal forces that act on an object from opposite sides but make the object move. Look at the image. The shorter person is trying to exert force to the left, which is the pink arrow, while the taller person is exerting an effort to the right, which is the green arrow. Notice that the green arrow is taller in length than the pink arrow. That means the taller person is exerting more force than the shorter person. This results in unbalanced or unequal forces. In this case, the object will move in the direction that the stronger force is pushing it to. So the object will move to the right side. Let's see the next example. Here we have the window arches of the Roman Colosseum. Look here. Here we have equal forces that are being exerted and they are opposite. So they are creating balanced forces and they are allowing the object to stay stationary. Okay, now for the net force, the total of all the forces acting on an object. Whenever the net force is equal to 0, the object does not move. Look at this example. Each side exerts 1000 Newton, so the force on each side is 1000. But the forces are working against each other. These forces are cancelling each other out. As you can see below, they are equal, so they are cancelling each other out. That means the net force is 0. When the net force is 0, the object does not move. Let's continue. When net forces on each side are not equal, the object moves in the direction of the greater force. Look at this example that we have below. The net force of the figures on the left is more than the net force exerted by the figures on the right. As you can see, on the left, the people are larger than the people on the right. Therefore, the seesaw moves in the direction of the greater net force. That means the people on the left have a greater net force, so the seesaw will move downward on that side, which is the left side.